Hey there, kids. Yay, guess what today is? It's word problem day. Woohoo! Don't run away. Come back. Word problem day, lesson 7, module 3, and Eureka Math, grade 5. So hopefully you're in the right place. I don't have any notes because we are using all the strategies that we have been talking about in lessons 1 through 6, and we're going to apply them all in lesson 7. We're going to apply them all and then some. And then we're going to use some and we're going to use some new stuff. So I'll show you how it's most efficient to answer these problems. I will try my best to teach you something fabulous today. Okay, so for lesson 7 problem set, it says solve the word problems using the RDW strategy. That means read, draw, write. You have to read first, of course. You have to draw something, and then you're going to write. You always need to write. I have lots of students who will not write a label with their answer, and they're like, woohoo, I got a number. And I'm like, but do you know what the number means? You have to know what the numbers mean when you're having them representing different parts. So it all kind of comes to fruition here in these word problems. So let's get into it, and you'll see what I'm talking about. George weeded 1/5 of the garden, and Summer weeded some too. When they were finished, 2/3 of the garden still needed to be weeded. What fraction of the garden did Summer weed? So we've got different parts coming in, and the best way to show parts that make up a whole is by creating a tape diagram. So these are going to really become your friend if you can just practice using these, okay? This represents the whole garden or the whole whatever. So George weeded 1/5 of the garden. Now, you don't have to worry about exact size representation, so we can just put a little space here that could be roughly 1/5. We'll just put George, okay? And he weeded 1/5. So we want to have a number and a name, or a number and a word. And then we've got Summer, and hers is the next name here, and she weeded some too, but we do not know how much. We'll figure that out. Now, when they were all finished weeding, 2/3 of the garden still needed to be weeded. And we do know this is 2/3 still needs to be worked on, okay? So all of this together is going to make a whole, which we don't really know, and that's okay. We don't even have common denominators here. So now is the time when we can combine what we do know. And when you look at what you have, you've got fifths and thirds, and we see that we need a common denominator. Now, I'm only going to do this for one of them, but then we're going to move on and just use that math that we've been talking about. So if I have fifths, 1, 2, 3, 4, 5 pieces, and this is 1. Okay, this is what's your area model. And then we have 2/3. Okay, this is using an area model to help you get equivalent fractions. So we have 1/5 here and we have 2/3 here, but I need equivalent fractions for the bottom. So what we've been working on creating is taking the model from the second fraction and laying it over on the first, and taking the model from the first and laying it over on the second. Those are not exactly the same size, but that's okay. But we do have at least 15 parts in each. Now, how did I get those? Remember, this is going to be what we do from now on. We're going to take those two numbers and we're going to multiply those bottom denominators together to get the 15ths. That is now your common denominator. We will get it by multiplying or by skip counting and finding the lowest common denominator. Now, how many are shaded here? Remember to take the denominator number from this other one and multiply it by the top to get 3. Double check with your model. Remember to take the denominator from this one, because we made fifths over thirds, and multiply it by how many were shaded here. So now we have 10. When you add those up, you find that there are 13 15ths that are now accounted for, okay? I like to label this, it's accounted for, because it's either George or still needs to be done, okay? But what we don't know is we don't know Summer's portion. And so what we do know now is that if I have 15ths, the whole garden is represented by 15 15ths. That's the whole. Okay? So if I have 15 15ths, that is the entire garden, and 13 15ths is accounted for, Summer's portion is what's left. So you're going to take your 15 15ths, that's the whole, take away what you know, and end up with what we were searching for, which is Summer's portion. So 2 15ths. So Summer completed 2 15ths of the weeding. Okay? And so that's what everything can look like. Remember, whole, parts add up to the whole, and then you can use your area model if you're not entirely sure of what to do with these common denominators or how to get the equivalent fractions. So let's move on and I'll show you how to do another one. Jing spent 1/3 of her money on a pack of pens, half of her money on a pack of markers, 1/8 of her money on a pack of pencils. What fraction of her money is left? Again, a tape diagram can show you parts that add up to the whole, and the whole would be all her money. Okay, and we don't have to know how much money she has, we just know that she has all of the money in her pocket. So if she spent 1/3 of her money on pens, we can say pens and then give that a value. Make everything fit in with the label that we need. Half of her money on markers, so we'll give markers a big chunk because that's half. 1/8 of her money on a pack of pencils, that's a small amount. Half is for markers, and then we've got 1/8 on pencils. And then we have some money left. That's a mystery. So what now? I've got 3 fractions that I have to combine so that I can see what's left. So when you have this is when I say, hey, let's skip count by our denominators. So line them up over here. Okay. Now what we need is we need to be able to add all these 3 fractions together that we know so that we can get whatever the denominator is total, just like we did up here. Whatever the denominator is, put that on the top to make that the whole, and then we'll subtract from it to find out what's left. So I need a common denominator between 3, 2, and 8. If this is times 1, remember this is the scale factor up on top, then the times 2, okay, I'm going to start with the biggest number. I've said that on previous videos. I do start with the biggest number because I'm looking for a multiple of the biggest that is a multiple of the smaller ones. So if 8 times 2 is 16, but 16 eventually is a multiple of 2, okay, when it's times 8, but it's not, 16 is not times 2, and times 8 we're going to be way up here. So what is 8 times 3? Okay, I've got 24. Now when I think about that, I think 8 times 3 is 24. So 3 times 8 is 24. And eventually 2 times 12 is 24. I will get to 24 using 2. So I can use 24 as a common denominator for all 3 of these because I can use a scale factor. Now my scale factors are on top. Okay, scale factor, don't worry about this. A factor is just a number you multiply, and scaling is going up or down. So I need to change thirds into 24ths. So I'm taking my 1/3, I'm going to multiply by a scale, I'm going to get 24ths. Look at what you used for 3. This is your scale factor. It's 8. Whatever you do to the bottom, you do to the top. Always, every single time, when you scale something up, the top and the bottom have to change at the same rate. So 3 times 8 is 24, therefore take your 1 times 8 and get 8. So my equivalent fraction is 8/24 for 1/3. And think about it, really. 1/8 is 1 part out of 3 to make 24. Okay, now I need to get from 1/2 to 24ths. And so if you want to write this out, times what equals 24ths? 2 times what is 24? The scale factor's up here, and it's 12. If 12 is on the bottom, 12 must be on the top. 1 times 12 is 12, and that makes sense that 12 24ths would be equivalent to 1/2 because it takes 2 12s to make 24. And then for the last one, from 1/8, I need to multiply by a scale factor to get to 24. What do I multiply 8 by to get to 24? Oops, and that's where the 3 was. Okay, so times 3, 3/3. 8 times 3 is 24, so 1 times 3 is 3. My new numerator here is 3. Now I can add everything because I've got 24ths all the way across. 8 plus 12, 20 plus 1, 23. So, what did we find out? We found out how much money is what? Spent. Did we find out how much money is left? No, we found out how much money is spent. So, money spent. That's where kids will oftentimes put this as the answer, and then I'll say, but what's the question? So go back. What fraction of our money is left? Well, how do we figure this out? Remember to take the denominator, call that your numerator as well in order to represent all the money. And then take all the money, 24 24ths, minus what she spent to get what is left. 1/24 of Jing's money is left. There you go. And so again, remember, read, draw, write. This is my writing, this is my drawing, and we already read it. Yay, hooray. Oh, and if you like these videos, click subscribe. Come back and you'll be notified when I upload new stuff. Mostly math, sometimes blah, 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 focus. Sometimes science, sometimes grammar, and sometimes it'll focus in a moment. There it is. Okay, so next page. Shelby bought a 2-ounce tube of blue paint. Oh, this one's really hard. I remember doing this with the kids the first years, and it was like, we really struggled with our tape diagrams. So Shelby bought a 2-ounce tube of blue paint. She used 2/3 ounce. And when they give you this, they're telling you that it's 2/3 of 1 ounce because it's less than 1. To paint the water, 3/5 of an ounce, which notice here that this is more than half of an ounce. Okay, not more than half the tube, but more than half of an ounce. 3/5 ounce to paint the sky, and some mystery number to paint a flag. After that, she had some left over. So how much paint did Shelby use to paint her flag? The mystery number. So now this one we found was easier to do if we had 2 different tape diagrams that you could kind of look at and think about all the fractional parts. At first, we're just going to take the 2-ounce container, and this is going to be all of the things she's painting. So it says we've got the water, and then we've got the sky, and then we've got flag, and then we've got leftover. Okay, so there are clearly these 4 parts that make up the 2 ounces. But for each of the ounces, it's really helpful if you make a separate tape diagram for each of the ounces, because the numbers, the fractions that they're giving us are in a fraction of ounces. And so it's really easy if we get a common denominator to show in the single ounce containers or the single ounce labeled pieces how we're making this up, and then we can figure out the flag amount. So what do we know? We know that 2/3 ounce is for the water and 3/5 is for the sky. We don't know the flag, but we do know we have 2/15 left. So with all of these fractions, you might recognize that 3, 5, and 15 are all compatible with 15. And so if I'm going to combine the numbers that I know, then I really just need to turn everything into 15ths. Okay? Now this we'll come back to, but I need equivalent fractions for these. Now I'm not going to put everything that I did on the previous page because you should understand about those scale factors. I need to get from 3 to 15. Okay, so my scale factor from 3 to 15, I don't even have my skip counting, but you can certainly write that out. But 3 times 5 is 15. Okay, 3 times 5 is 15. If 5 is my factor on the bottom, 5 is my factor on the top, so I will get 10 here. Okay, I'm using 5 as my scale factor. I'll just put it right here. Okay, 5/5. If fifths is changing to 15ths, then my scale factor has to be what? Times 3/3. 5 times 3 is 15, therefore 3 times 3 is 9. Okay, and then this one, guess what? It doesn't even change. We're just going to copy it. It's already 15ths. It's already compatible. Now I can see that when I have all these 15ths, that it's going to create more than 1 full ounce, which is okay because the tube is 2 ounces. But when you divide your 1 ounce piece into parts, you want to make 15ths. So do 3 even sections of 5. It'll help you if you just break it into 3 pieces first. And then do real lightly 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So make 15ths. Do it again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I've got 15ths for each of my 2 ounces, or each ounce that adds up to the 2. Now I can label what each one is, okay? Noticing that you're going to keep everything labeled very clearly so you can see what you're looking for. So for water, I have 10 out of 15 that are accounted for water. That's these 5 and these 5, and that's all water. That's all of this here. Okay, and you can even, if you have pens handy, you can do a little bit of coloring just to make sure you know that's for the water with that blue. Then we've got 9/15ths for the sky. So we're going to finish out this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. And all of these are going to be for sky. And we can use a different color. It doesn't have to be blue. It can be a different shade of blue. It's not the color that's important. It's the fraction. And then you would say sky. Okay, so this is all getting accounted for. Now I have 2/15ths that are accounted for the left. So we can do 1 here and 1 here. And this is left, which gives you a little bit of a clear picture of what the flag was. Okay, now when you look at the pieces, you can count them up knowing that this was 1, 2, 3, 4, 5, and then 6, 7, 8, 9. If you would like, you can write that here, and you can kind of point to it. 9/15ths used for the flag. How much did she use to pay used for the flag? You can also mathematically do the 10 and the 9 for 19, 20, 21 and see that this is greater than 1 to show your mixed number. 1 and 6/15ths are used. 1, 2, 3, 4, 5, 6. Okay, and that's used, but that's not what we're searching for. That's just showing another piece of your tape diagram. Okay, but you want to make sure you identify that 9/15ths is used for the flag. Okay, what else could you do? You could take your 30/15ths, which is all the 15ths. You could take away the 21/15ths to show the 9/15ths that are left. So mathematically you can solve for that. Okay, so the picture can help you, but if you're really struggling with your picture, you can just use the math. Anyway, lots of different ways to go about that, And I hope those are all helpful. But we still have a couple more, so let's move on. Okay, Jim sold 3/4 gallon of lemonade. Dwight sold some lemonade too. I wonder who sold more. Together, they sold 1 5/12 gallons. Who sold more, Jim or Dwight? How much more? I'm sure they had a fun competition. It's referenced probably to The Office. Somebody must be a big fan. So let's take a look at these parts. The part that Jim has, the part that Dwight has, and then the whole. Make a tape diagram. We do know the whole this time. 1 5/12 gallons. That's everything they sold. And we've got Jim and Dwight. Let's just say J and D, and we don't know one of them, but we do know Jim sold 3/4 gallon. Mystery for Dwight. So label your parts. And now we need to look at the whole, take away Jim's portion. So if I have 1 5/12, and I'm going to take away what I know, and they don't have a common denominator. Again, this is where I'm going to say, don't make 48ths. Good heavens, no, no, no. If you need to, skip count over on the side. 4, 8, 12. That's times 3 scale factor. And this is times 1, so we don't even have to change that. The goal is to not have to change much if you can. So what can I do here? Well, remember that a whole number can be any fraction. Since I have 12ths and I want 12ths for my common denominator, I can have 12 12ths instead of 1. This is 1. This is 1. So if I have 12 12ths and 5 12ths, that makes up 1 5/12. So this is my total. From that, I'm going to subtract some 12ths that we will make 3/4 into. So if you want to write it over here, times what scale factor equals 12ths. Here's my scale factor. It's 3/3 because 4 times 3 is 12. So 3 times 3 is 9. Now, when you have a subtraction problem, this is that new way. You can change this to 12 plus 5 and get 17 and do 17 minus 9 if you want. But I'm going to try to keep you with that new way, which is very cool. Take the 9 away from the 12. So use 12 12ths minus 9 12ths. Get 3 12ths, and then just do the put back. Put back the 5 12ths, and so you get 8 12ths. If you really want to, you can do the 17 12ths minus 9 12ths, and you'll still get 8 12ths that way too. Okay, that works fine. But this is just kind of cool when you take from the one whole. Okay, so take this away from the whole. And so what we have figured out is we've figured out that Dwight sold 8 12ths gallon. So all that to figure out what Dwight sold. Who sold more lemonade? That's our other question, Jim or Dwight. So now that we know how much lemonade Dwight sold, we have to figure out the difference between Jim's amount and Dwight's amount. Well, let's take Jim's amount that we have the common denominator for, the 12ths. So if Jim is 9 12ths and Dwight is 8 12ths, it looks like Jim won this battle by 1/12 gallon. Jim sold 1/12 gallon more. And that is your answer for number 4. I hope that makes sense. It's kind of involved. I know it's kind of busy, but I'm just trying to write everything so that you can see what I'm thinking. And finally, the last problem. Okay, Leonard spent 1/4 of his money on a sandwich, and he spent 2 times as much on a gift for his brother as on some comic books. It's confusing because you want to say he spent 2 times as much as the sandwich amount, but that's totally unrelated. He had 3/8 of his money left. What fraction of his money did he spend on the comic books? Let's make a tape diagram again. Okay, these are so helpful. We've got sandwich money. We've got the gift for the brother. We've got comic books. We've got money left. So we have 4 sections. These are not in the proper size, but that's okay. We're just working on what pieces. We actually know he spent 1/4 of his money on the sandwich. And we know that whatever he spent on the gift, it was double the comic books. Okay? So whatever this is mystery number times 2. So we'll make a better tape diagram in a second. Then he has 3/8 of his money left. So what we can do here is we can look at these 2 denominators. Again, I want to have a common denominator so that I can show the parts. Okay? So let's make a tape diagram and turn it into eighths. Okay? 8 parts. Half the left, half the right. Let's make 8 little chunks here. Okay? Now, I would like to have a common denominator. So I'm going to do a little work over here. I want to have eighths. So I need to multiply by a scale factor to get eighths. What can I multiply 4 by to get 8? 2, you say. You are right. So my equivalent fraction for 1/4 is 2/8. So I can say sandwich is here. Okay. Now 3/8 is already in eighths form. So this one is also accounted for with money left. Okay. So that's already in eighths, 3/8. There you go. Now, again, thinking about the comic books and thinking about the gift being 2 times as much, what do we have here? Well, we have the actual 1, 2, 3 pieces left. If the comic books are 1, then the gift is double that. Then the gift would be 2. Comic books are 1/8. Comic book. The gift would be 2/8 because it's twice as much. Remember, twice as much would give you double that. Okay, so 2/8 is the gift. So what fraction of his money did he spend on the comic books? The comic books is the 1/8 when you go back to the picture and the question, and now we're going to write it. He spent 1/8 of his money on comic books. Hooray. So complicated, I know. Sorry, I didn't write these things, but if you can do these, man, you are so prepared for state testing and you're prepared for 6th grade. So thanks for hanging in there, and hopefully we will see you on the next video. Click subscribe, come back again. Bye for now.